Welcome to the live video. Today we want to deal with more of calculations on upthrust and density. Calculations on density and upthrust. So we are going purely calculations, and if you have anything to ask us, you can go ahead. Now, let's take the number one question we have here. Some questions have been sent by some students before the program. They will send us questions on WhatsApp. We can attend to them. This one said a simple hydrometer of mass 50 gram float in a liquid of relative density 1.4. Say calculate the volume of the liquid. Calculate the volume of what? The liquid displaced by the hydrometer. Now, when the liquid floats, we understand that what? That the mg of the hydrometer is equal to what? Density times volume times gravity. So that is the formula to use. That is the formula. This is the volume of liquid displaced. This is the density of the liquid, and that is gravity. This is the mass of the object that goes into the liquid, which is the hydrometer mass. So let's say this one cancel out this now. What do we have? We can have mass of the hydrometer equal to density of the liquid and volume of the liquid displaced. Now don't forget that volume of liquid displaced is equal to volume of the object when it is totally in mass. Go and watch all the video part 1, part 2 of our live videos on my page. So what the volume of liquid displaced is equal to mass over density of liquid. Now don't forget density of liquid, we can convert 1 gram per centimeter cube. 1 centimeter cube is the density of water in gram per meter cube. Meaning that for every 1 gram of water, or 1 gram of water is found in every 1 centimeter cube of what? Of water, or 1 gram of mass is in 1 centimeter cube of water. So we convert, if you would have 1.4 times 1, we would have 1.4 gram per centimeter cube. So I've converted the what? The relative density of what? Of the liquid to density. So we can now put it there, 50 gram divided by what? 1.4 gram per centimeter cube. So we are going to have the volume of liquid displaced, which is what? 50 divided by what? 1.4, so that we can have it as what? 35.7 what? Centimeter cube. That is the volume of liquid displaced. That is number one question. Let's go to number two question now. Number two. They said a meter weigh 1.8. A meter, if you have a question to ask, you can send it to our list. Weigh what? 1.8 Newton in air and 1.6 Newton in water. He said what? What is, or what will be its weight in a what? Liquid of relative density. Anytime you see me RD means relative density. Relative density is 0.65. Now this is the what? A questions number 2 that come our way. Now please pardon me to tell you this. In our last class, I failed to tell you, that's why I even accommodate this question. To tell you that relative density is equal to upthrust in liquid, it escaped me, but thank God for this class. Go to Upthrust in water. Please just pardon me for this. I think that is the only thing I did not give you. Now, Upthrust in liquid is equal to what? Weight in air minus weight in liquid. What is Upthrust in water? So weight in what? Air minus weight in water is equal to what? Relative density. Now, don't forget that weight in water is the weight of the body when immersed in water. Weight in liquid is the weight of the body when immersed in liquid. We can also similarly write it as what? If you cancel out the mass, you can write it as mass in air. Many of you are familiar with it. Mass in liquid over mass in air minus mass in water. Please take note of that. Now, what we are going to do now, what they say we find, what will be its weight in liquid? So we are looking for this. So we are given relative density as what? 0.65 is equal to what? What is weight in air? 1.8 Newton minus, what about what? Weight in water or in liquid unknown. What about weight in air again? 1.8 minus, what about weight in water? We are giving us 1.6. Then what we are going to do is to play with it. Don't forget that 0.65 is actually what we cross multiply with what we have here. Now, first of all, 0.65 we multiply 1.8 minus 1.6 will give us 0.2. So 0.65 times 0.2 we cross multiply equal to what? 1.8 times weight in liquid minus weight in liquid. What we did is that 1.8 minus 1.6 is equal to 0.2. Then use it to cross multiply. 0.2 times this, then 1 times this. So how do you make WL the subject of the formula? WL becomes what? 1.8 minus 0.65 times 0.2. 0.65 times 0.2. You can confirm it wherever you are so that you can know that you are following us. 0.13. 0.1 what? 3. 0.13. So if you subtract now, what do we have? We have 0.1.8 minus 0.13. Please, as you are in this class, please try and come with your calculator to make sure you are following us. As you are doing it, you are also doing it. So that is just that. Weight in liquid is equal to 1.67 as our answer. Please take note of that. Very, very important. We go to the next question. Now, this question says, let's take this one. Now, a 40 centimeter cube, that's number 3 for today. Number 3 question. Let me look for, okay, let me use this thing. Number 3 question. Let me take number 3 question. Now, it says that what? Number 3. A 40 centimeter cube or 40 centimeter cube of liquid Y is mixed 60 centimeter cube of what? Of X. It's mixed with, what will be with? 60 what? Centimeter cube of X. Now, what he's saying we should go and do now, he says what? He said, if the density of X and Y are, or density of y and x are 1.00 kilogram per meter what cube and 1.00 kilogram per meter cube. Say calculate what is. Now what we want to do in this question now, they are giving us question that has to do with mixture. So in that case, if they are giving us question that has to do with mixture, what you should be expecting them to tell us is what? They say, what is the what? The density of mixture. Mixture. Now, we are what? Having what? Volume of y mixed with what? With 60 centimeter cube of x. If the density of y and x are what? This and this. 1.0 and 1.6. Sorry, 60. What is the density of the mixture? Now, I gave you, go and ensure you watch, because what we use in solving question is that you can carry diagram. It's a diagrammatic question that will make you, well, maybe in the diagram you can illustrate better. You take your data, then you choose a suitable formula. This is a suitable formula. Then you solve. Those are the three parameters you will have to what to solve, or three things that we need to solve question. Now, density of mixture is equal to mass 1 of y plus mass of x over volume y plus volume of x. So what do we have now? It means that this one, now don't forget that mass is equal to density times volume. So if you check this question, mass is not given to us, it's dealing with liquid. So we're going to have what? Density of y times volume of y plus density of x times volume of x, all over what? Volume of y plus what? Volume of x. If that one is not, maybe we are giving only mass. If it's talking about alloy, that means it's talking about a solid body. Most likely to be mass of y plus mass of s, if they are what? Not liquid, over what? Mass. Density is equal to mass over what? A volume is equal to mass over density, volume. So in place of this volume now, I will replace it what? With mass of y over density of y plus mass of s over density of s. So these are likely what formulas to be used depending on the case and what parameter is available to you for solving of that question. Now what we are going to do now, since we have our formula, let me clean this side so that it will not mix up. Let us now what? Input all our parameters there and solve them accordingly. Let's input all our data that will have been listed, on the board, then we solve. Now, what do? We put what? Density of what? Of y is what? Density of y is 1.00 kilogram per meter cube. Then density of x is y now. Y belong to this, y x belong to the second parameter. That's why, in fact, you're supposed to put respectively. Yes, in that question. So the person that sent us that question is supposed to put respectively. So this one will now give us what? Dx is equal to what? 1.60 kilogram per meter cube. What is volume of x? Volume of s is given as what? This for s, 60 centimeter cube of x. What about volume of y? The volume of y is what? 40 centimeter cube of y. Now, having known that, then what you just need to do is to what? The best formula to be used for this question is this one that I circled. The best formula to use. So what is your dy? Dy is what? 1.00 times, what's our vy is 40 plus, what's our vx or dx is what? 1.60 times, what is our vs is 60, then divide by what? What is our vy is 60, or no, vy is 40 while dx is 60. So when you press your calculator, you get your density of mixture. So that is what we're going to do. So once you do that, you are good to go. So what we're going to do now is to what? Calculate. So this one will give us 40. 1 times what? It was 40 plus 1.6 times what? 60 is equal to what? 96. Divide by what? 100. So 96 plus what? 40 will give us about what? 136 divided by what? 40. Divided by 100. So what I want to have at the final answer will be 1.36 what? Kilogram per meter cube. So that is the density of mixture you are going to have. You can always confirm them on your own with your calculator so that we can know whether we are okay with it or not. Question 4. So we are going to question 4 because time does not permit us. We want to make sure we cover all the areas that can be asked in the what? In a question on density. Now, this is another very interesting question. This one even came out in one university exam, now Uniben University exam, and even for A-level exam, 100 level. An object, it came out in pursuit TME also, of mass. OAU, Obafemi University, also has, or some of the good universities, they ask this question. Very, very interesting. And density, it might not be the same value, but the same concept. 600 what? Kilogram per meter cube is suspended with a spring, so that what? Half of it is immersed in what? Immersed in paraffin of density, in paraffin of density. So I can clean this right now. Paraffin of density, 900 kilogram per meter cube. Now, what did they say we should find now? They said, full stop. Find the tension in the string. Find the tension in the string. Now, in this question, we want to find tension in the string. So, in that case, we have to be very careful. I gave you a formula relating tension when you suspend a body in water. Now, there was a question somebody asked me. You understand? I said, any question they ask me concerning a particular topic, I'll bring it to the house. Now, the question is that somebody dip, because it has to do with this. Somebody carry a bucket, tie a rope to it, and dip it inside the water. On bringing the bucket out of the water, the bucket just cut. He was then asking me what really affected that particular tension as it comes out of the water. Now, the weight in the water as you fetch the bucket, your stamina, is less because what? There is an assistant called Upthrust, which reduces the weight in water. But as the bucket lifts the water and come to air, the tension now, or the force on the tension of the rope is now increases, thereby making the rope to cut. So that is to say, that means that as there is an increase in the tension that makes the rope to cut. But if it's in water, there is an assistant called Upthrust that makes the rope not to cut. Now, T is equal to what? Mg minus U. I gave you this formula in the last class. I don't have time to be driving any formula again. This is a formula. That's why you must ensure you do what they call follow up. You might not be live in the last class, but go and rewatch our video of the last class. Very important, my dear, so that you can follow up. Now, what is tension? This T is tension in the in the string. T is the tension in the string. Don't forget. What about the what? M. M is the mass of the what? Of the body, which is equal to what? Density of the body of the object times what? Volume of the object. The same one. In case you are not giving mass, that's what you are going to use. Then what is your G? G is 10 meters per second square. Acceleration due to gravity. Then what is your U? U is upthrust, which is equal to what? Upthrust, or what we call lost in weight. Lost in weight. Or what we call the weight displaced in water or in that liquid. And that what upthrust is equal to weight displaced in liquid. You have density of liquid, that is what? The volume of what? Liquid displaced times what? Gravity. Now don't forget that volume of liquid displaced is equal to the amount in water. If you check this question now, they say half of it is what? In paraffin. Paraffin is the liquid now. So that means that what we add is half of the what? The entire volume of the object. The volume of the object is used. So what amount of the object is in water? That's what we call the what? Volume of liquid displaced. And don't forget, you can always get what? Volume of the object by what? Saying mass of the object over density of the object. Please take note of that. Very important, you know that. Most of the time, they don't give us density, volume of the object. So mass of the object divided by density of the object. Why do I take half volume? Because it's only half of the entire what? Object that is inside the paraffin. So that's why I take half. So in that case, we are going to have half times what? What is the mass of the object is what? Don't forget to convert the object to what? To kilogram. But what we are giving here, according to the question, the mass is in gram. I have to convert to kilogram. And for me to convert to kilogram, you divide by what? So if the mass is given as what? 400 gram, it means that divide by 1000, you take it to kilogram, which is 0.4 kilogram. Let's take note of that. So 0.4 kilogram of mass divided by what density of the object itself? It is 600 kilogram per meter cube. So what we are going to have now to know the volume of liquid displaced now is what? We are going to have 0.4 divided by what? 600. What do we have? Times what? 0.5, which is 1.1 over 2. So we're going to have it as what? 3.333 times 10 to the power. You can do a confirmation as you are sitting down. If you notice any discrepancy, please quickly send a message to us and then we will correct it. We are for you and you are for us. Now, look at it. Don't forget, the person that is solving is a human being. So there's nobody that is on earth that is perfect in terms of. So maybe where I press the calculator, there's a mistake somewhere. You notify us. Just notify us, then we'll try. If it's correct, we'll still tell you it's correct. There are people that are following our page that are also monitoring everything that is happening. They are also science students and they are also experienced in the field. Some of them are graduates also. They are also following what we are doing so that we can always be carried along. Now, we have that as the volume of the liquid displaced. Now, since you have gotten our parameter, let us input them accordingly without rushing. Now, the tension now, don't forget the tension now, we have gotten our parameter, that's why I clean the question. It's equal to what? What is the mass? The mass already is what? 0.4 times, what is the gravity now? The gravity is what? 10 minus, I want to have the dust please, that's why I clean the board. The upthrust is what? What is upthrust? Upthrust is density of liquid. What is density of liquid? That you have written the question that you have not written it. Density of liquid is what? 900. 900. Then times what? Density of liquid. Density of liquid is 900 kilogram per meter cube. So what about the what? Volume of liquid displaced? We have already solved for that, which is what? 3.33 times 10 to the power minus 4 times what? What is our gravity now times 10. So once you do that, you'll get your answer. So what we're going to do now is to multiply the answer I've gotten before. I did not remove it, times 900, because I have this on the screen already on my calculator. I approximated this is about what 3.33333 thereabout, times 900 times what 10. So that will give us 3 on the dot. If you actually what in your own pressure, I would have 3 point something, 1 something. So this will give us 3 on the dot, 3.0. Then this one will give us what? 4.0 Newton minus 3 Newton. Well, what will now be our attention? 4 minus 3 will give us what? 1 Newton. So this is what the spring balance we read. The spring balance will read what? That means as the body is placed in paraffin, the spring balance will read 1.0 Newton. That is what it's going to read. Let's go to the next question, please. There's no time. The time is fast spent. Now, this one says, a body. Let's take this one first. He said, a relative density bottle. Let me write it there so that people are writing at home. A relative what? Density bottle weighs what? 30 grams when empty, 70 grams when filled with what? Filled with what? With water, and 100 grams when filled with what? With liquid. Find the what? The relative density of the liquid. Now this is a question we need to solve. This is question 5. Question 5. Now, this one now, they gave us, they say a relative density bottle, what? Weigh 30 grams when empty, 70 grams when filled with water, and 100 grams when filled with liquid. Find the relative density of the liquid. Now, you have an advantage of rewatching the video over and over again. So anyone you cannot write, don't be what? Don't worry. You can just listen and understand it. You will rewatch it later again. So you can rewatch it later again and write down whatever you cannot write. So what I will advise you at this point is just to listen and compare. So when you now go through the video again, it will be far better than somebody that did not join us live. So that is it. Now, the relative density bottle weigh what? Empty what? Relative density bottle is what? 30 grams. Now, when what? Filled with what? With water. That means empty what? Relative density bottle plus water is equal to what? 70 grams. Now, empty what? Relative density bottle again plus what? Plus what? When filled with liquid plus liquid is equal to what? 100 what? Gram. Now, what did they say we should find? Find the what? The relative density of the what? Of the liquid. Now, what we're going to do now is what? Relative density of the liquid. Relative density of the liquid is equal to what? To mass of the what? Bottle plus what? Liquid minus mass of what? That means empty bottle now. Minus what? Mass of empty bottle over mass of empty bottle plus what? Water minus mass of what? Empty bottle. That's the formula you want to use to get it. So anytime you see question on relative density, but this is a very popular question, that's very common. So mass of bottle plus liquid is what? 100 minus mass of empty bottle is what? 30 gram. The mass of what? Empty bottle plus water is 70 gram minus mass of empty bottle is what? 30 gram. With your relative density of what? Of the liquid. So how do we find that? This one will give us what? 70. While this one will give us 40. This one will cancel this. Now that 1 point what? Remember 3 add 0 to the 30. 30 divided by what? We would have 7, 5 thereabout. So you can press your calculator to confirm it. Don't mind me, I like to play with numbers. So let's confirm it's correct. So that is just that. That is the answer. We go to what? Question 6. Question 6. Question 6. Question 6. Don't forget this class is a 1 hour class, so that's why we are trying to meet up to make sure that we cover all the relevant areas of questions that you could encounter in the examination hall. Now this one says, question 6 says what? What volume of alcohol will density of 8.4 times 10 per 2 kilogram per meter cube will have the same mass as 4.2 meter cube of petrol, whose density is 7.2 times 10 per 2 kilogram per meter cube. Now let's go ahead. Now before we go ahead, please, as you are watching this video, if you have not subscribed, just click the subscribe button now and continue to follow this class. So that when we even post any videos, either in physics or maths, we can always get them. Now the question says the what volume of alcohol with density 8.4 times 10 per 2 kilogram per meter cube we have the same mass as 4.2 meter cube of petrol, whose density is what? Is 7.2 times 10 per 2 kilogram per meter cube. Mass is equal to what? Density times volume. Don't forget, density is equal to mass over volume. And since mass is constant for what? For this question, mass is what? Is constant parameter. Now, since mass, they've told us in the question, they say we have, so that means petrol and alcohol, we have the same mass. Therefore, density of alcohol plus volume of alcohol equal to density of what? Petrol times what? Volume of petrol. So that's what I want to use to get our answer. When you do that accordingly, what are we looking for? We are looking for volume of what? Alcohol. So volume of alcohol now becomes, that means the Bible said by density of alcohol, we are going to have density of petrol times volume of petrol divided by what? Density of what? Alcohol. So when you do that, you get your answer. That is okay. You are going to have what? Petrol has what? Density of petrol is 7.2 times 10 per 2 times volume of what? Of petrol is 4.2. Well, what is density of alcohol? 8.4 times what? 10 per what? 2. So this one will cancel this one. This one will cancel this one. This one will cancel here 1. This one is 2. That means I want to have what? 3.6 meter cube. You can confirm it. So that's what I want to have. I think that is very, very clear. So we go to the next question, question 7. Question 7. One thing about physics calculation, if you are not careful, we will not solve more than 2 questions for within 1 hour. If you are not very careful, that's one thing. And that's one thing we must learn. You must learn to be fast and what? Accurate when solving questions in physics. Very, very important you do that. Very, very important you do that. Learn how to be fast and also learn to be what? To be accurate. Now, there is one question I want us to solve here. This was said, an 80 kg what? Man floats. Number 7, float with what? 4% of what? Of his volume above the surface of what? Above the surface. Above the surface in fresh water. Now, the question asks, what is the volume? Question mark. Now say what volume? What volume would what? Be what? Above the surface in seawater. How great is the upthrust? Upthrust on him in air due to what? No, the what? Due to the what? The air what? It displaces. Take what? Density of seawater to be equal to what? 1030 kilogram per meter cube. Density of fresh water is equal to what? 1000 kilogram per meter cube. Then density of what? Of air is 1.225 kilogram per meter cube. So that is what we are given in the question I want to solve. This is a very technical question that I want you to listen. It's a very technical question that I want you to listen. Very, very important. Very, very important. The question was sent to us, and we are about to do justice to it. Anytime you see a topic being what? Sent to our page that we are going to be doing, or my Facebook page, please, most of the times, all the topics I want to do, I always send to my Facebook page and my TikTok page, which is what? Engineer Holiday. In full, just go and look for Engineer Holiday on TikTok or Facebook. I will always send the topic ahead so that you can know the topic and prepare ahead of what time to know the topic we are doing. Very important to do that so that you can get yourself prepared. Now, we have what? A 80 kg man. The mass of the man is 80 kg. Float with 4% of his volume above the surface in fresh water. Let me take a diagram. We need a diagram here because this is a technical question. Now, let's say this is the body. This is the body involved. Then this is what? The water, the fresh water. Now, don't forget that fresh water, it has a lesser density than seawater. Seawater always, most of the times, contain what? Salt. And their density, most of the time, deliberately increase because they are not fresh. They are not pure. Let me put it that way. Now, that is just that. Now, 4% of this what? Of this, the whole body contains 100%. Its volume of the object is 100%. This is 100%. The 100% is named as 1. So that means this volume is everything is 100%. So if 4% is above the water, what will be inside the water will be what? 100% minus what? 4 will give us what? 96% is what? Inside the water. Please remember that. 96%. If 100% is the entire body itself, that means the body of mass 80 kg. This one is 80 kg now. Is what? 100%. 4% is above the water. 90%, 96% is inside the water. Why am I interested in what is inside the water? That's the question. Because for every question, there is an answer. Now, why I am interested in what is inside the water, it will be equal to the volume of liquid displaced. So the volume of liquid displaced is equivalent to the object in water. Let me shade it differently so that you can see it now. Yes, now. So that you can see it. Seeing it will make us happy. That is it. You are not seeing the diagram clearly now. So that white portion is 4%. the 96% is the remaining one. Now, in fresh water, what is the volume of the object? Now, volume of liquid displaced is equal to what? 96% of volume of the object in what? In fresh water. So what is the formula we're going to use now? The formula we're going to use now will be what? The what? We are looking for what? The mass of the what? Of the object times gravity, because they use the word float. And since float has come in, is equal to what? Density of liquid, volume of liquid displaced times gravity. This is the what? The principle of flotation now. Anytime a body float, that is the formula to use. Please take note of that. Now, what is the mass of the what? Object? 80 gram times 10 because what is density of liquid it floats in the fresh water? It what? The fresh water what it floats in is what? 1000 times what is the liquid displaced? Volume of liquid is 96%. What is 96? 96 over what? 100, that is 96%. You convert to fraction, or you want to convert to decimal, 0.96 times volume of the object times 10. That is what we are going to do now. Now, when you do that, what do you do? This one will cancel out this one. Then this will cancel this. This will cancel this. What we are going to have is what? 9600 V naught equal to what? 8. Now, what I would have? 9600 divided by both sides by 9600. What do we have? So, volume of the object is equal to what? 80 over what? 9600, which will give us what? What will be our answer? That will give us what? 80 divided by what? 9600. We have what? 0.0083. Let me confirm it. Sorry. Don't forget that this is what? 960. Sorry. Thank God I saw it. 10 times what? 96 is 9600. So this 9600. Thank you. So that will give us what? 80. These viewers at home, just help us be checking so that anytime we notice anything, we what? So this one will give us what? 0.08333, which is the volume of meter cube. So that is volume of the object. So volume of the object got what? 0.0833 meter cube. Well, the most important thing you must note there is that don't forget this formula. And number 2, volume of liquid displaced is the amount of volume of the object in water or in fresh water. And that's what we have done. Please, very important, you need to go and watch that remaining video so that you can know where you are. Now, we are done with this now. We are done with this first part now. Now, let me clean this out so that we can see clearly. Let me clean from here. What volume will be. Now, don't forget our parameter is given to us and all that. Now, the next question, what volume will be above the surface in seawater? In seawater. Now, first of all, let's use what? Density, what we're going to use now. Because the volume of liquid displaced by the object in fresh water will be the same as the volume of liquid displaced by the object in seawater. I've said that thing. The volume of the object of the what? Of this body displaced in fresh water will be the same as volume of liquid displaced in seawater. It's just that what? The sinking level, the volume that will be above the water will not be the same. Don't forget that it will sink more in fresh water than in seawater. That means you have more what? More percentage above the seawater than fresh water, because fresh water has a lesser density. It's lighter water compared to a what? One that is heavier based on their density. So take note of that. Now, we have what? The volume density of liquid of fresh water times volume of liquid displaced by fresh water times gravity is equal to what? That means the what? The body will have the same upthrust. The body will have the same upthrust. Upthrust in fresh water is equal to upthrust in seawater. So density of what? Of seawater times volume of liquid displaced by seawater times gravity. So that's what I want to use. Now, what is the volume density of object of fresh water? 1,000 times. What is the volume of liquid displaced by what? Is 96 over 100 in water of the volume of the object. Is equal to what? What is the volume of the liquid or density of the seawater? It is 1030 times. What is the volume of liquid displaced? Which is the volume that will be inside the water. That is what this one means. Is what? VL times G. This one times G also. Now, what are we going to do now? What I want to do now is what? Work with this parameter and see how we can get our answer. Now, what to find, if you find the volume of liquid displaced. Now, listen very well. Let's take what? S percent. If S percent is what? Let's say, let me draw another this here. Let's say this is what? The volume of the object. But in this case now, there are more what? Volume above. There is the more what? This is seawater. But if you check the amount of percentage up is higher than what? The one here. Why? Because this density of this water is what? 1030 is higher than this one is 1,000. So the amount of what? Volume of object above will be more than volume of object above here. Because the water is more, is thicker compared to what? Density means denser. Density, this one is denser than this one. So the body will not be, but although it will have but the same upthrust. The upthrust here is same as upthrust here. That's why I use that formula. Now listen, if everything is what? Let's say from here, the volume what? Above, let's take it as what? Or volume inside the water, let's take it as X. Then, or let's take the volume above as X. And volume, everything, let's say is 1. Everything here, volume is 1. Then the volume inside, the fraction, the percentage of what? Of above is what? X percent. If X percent is above, what will be below? 100% minus what? X percent. That's what going to be below. So that's what I'm going to use now. That means let S percent be the volume above. Then let what? 100% minus S percent be the volume below. So that means I would have 100% minus S percent times what? Volume of the object times gravity. So if you do that now, quite all right. Now what we're going to have is that we're going to have it as G, we cancel what? G. Then object, this one will cancel this one. So what I would have now, I would have what? This cancel this cancel this. So what I would have 10 times 96, you have 960 is equals to what? Don't forget they have the same volume, the same gravity, just the density that different. So 130 into bracket what? 100% is what? 1% minus S percent is what? S over 100. So let's play with it now. Let's play with it. So what I want to have now is what? Divide both sides by what? 1030. So I'll cancel this one. So what I want to have now is what? 1 minus S over 100% equals to 100 is equal to what? 10960 divided by what? 1030. We have what? 0. What? 93220 and thereabout. Now, what do we do? Take this one to the other side and bring this one here. What do we have? I want to have it as what? 1 minus 0.9320 equal to what? S over 100. What do we have now? I want to have it as what? 1 minus what? We have 0. What? 067 96 times 100 to get our S. What do we do? To get X now, what do we do? We are going to have what? To get S, we are going to have what? 60 what? 7 point what? 1 2. That means times 100 was 6.7 0.96% is equal to what? S. Now, I haven't gotten that percentage, that means S percent now. Because S is a percentage now. Now, what we're going to do now is what? Find the volume that will be above. So the volume above now, volume above is equal to what? 6.796 over 100 times. What is the volume of the object we calculated for? 0.086333. Now, what we are doing now, because our answer cannot be percentage, it's going to be in meter cube. So you have to multiply your S percent times. We already know the volume percentage that will be above, multiplied by the volume of the object itself, so that we can know the what. What do you have now? We want to have what? 6 point what times 100, then times what? Okay, divide by 100 back rather. Divide by 100. So we have times what? 0.0833 as listen. So I would have 0.0 what? 0.0056 as the answer, meter cube. So that is the volume of the object that will be above in seawater. Why the percentage of what object above is what? 6.7% or 6.8% in case the examiner asks you. Now, the last part of this particular question is, what is the upthrust of the body displaced in air? Look at it. The upthrust of the body displaced in air. What is upthrust? It's not very hard. Upthrust, it will displace in air. So the density of air times volume of what object. Because when a body displays a volume in air, it displays the entire body. Hello, it's in air. So a body cannot displace one part of its volume in air. No, it displays the entire volume of the of the object in times gravity. So that would give us density of air is what? What is density of air? We're going to have it as what? 1.225 we are giving times what the volume of what of the object? 0.0833 times 10. Now, please, I will beg in the name of God, in case we did not answer your question because of time, send it to us. We will do video with your question and send it to our playlist. You understand? The playlist, that means you can still get it immediately. We send the word. Just click the notification button so that you can always get what? Our question. Help me click the notification button, so that anytime we post a question, you will get it. So we have just few minutes to go. 1.225 times what? 0.083333 and times what? 10. So we are going to have approximately 1 is what? 0. Let me say 1.002. So that's what we want to have. Don't forget density. If they give you density of air, any density given to you is what you are going to use. Don't use your own. Use the density given to you, they use to solve, which is what? Newton. So that's what we want to use to solve the question. So I believe that one is clear. I will solve one more question. Please, I will also solve some of these questions in our playlist. So in case you did not solve everything that we have here, we are going to what? Also solve some questions and place in our playlist, because this is almost time. And again, if you have any question to ask, please also ask us. Don't forget, let me just quickly summarize what we have done so far, because time might not permit me to write the question and also solve. So please take note of that. Make sure you go through the video over and over again. Don't forget to go through the video over and over again. I want to do a summary of what we have done so far and what we did. Now, we have talked about density to be equal to mass over volume. If the mass is constant, we say density of 1, volume 1, equal to density 2, volume 2. That is what, when the mass is constant. Then we also say density of mixture is equal to what? Mass 1 plus mass 2 over volume 1 plus volume 2, or density 1 volume 1 plus density 2 volume 2 all over what? Sorry, this is 1 2. Then volume 1 plus volume 2. What about if you have to calculate what? The upthrust. When you want to calculate upthrust, or probably you want to calculate density of what object, mass of a body, you can say mass of the sand minus when it is empty over the what? The volume of the container. Can get that one and get it good. Now, one other question that is common, upthrust. We say upthrust is what? The density of liquid, volume of liquid displaced times gravity. And it's called to what? Weight in air minus weight in liquid, or weight in water, depending on where they immerse the body. We have also said that what? Relative density is equal to what? Density of substance over density of water, or weight in air minus weight in liquid over weight in what? Air minus weight in water. Don't forget, this is relative density of liquid. We have also said that what? You can also have it as mass in air minus mass in water or in liquid, or mass in air minus mass in water. We have also said that what? Tension is equal to what? Mg minus what? Upthrust. When a string suspend a body into what? In water. Don't forget that upthrust is what? Is the liquid or weight of liquid displaced. It also means lost in weight. Weight in air minus weight in liquid. That means you now do mg minus what? Density of liquid, volume of liquid displaced times g. So that is what? Volume of liquid displaced is what? When it is displaced in totally in mass in water, it is volume of the object itself, which is equal to what? Mass of the object over density of the object. But when this volume of liquid displaced is not equal to mass volume of the object, it means that some parts, some fractions of it, maybe 3/4 of it is in water. That's what we are going to consider as volume of liquid displaced. I think this is already 9 on the dot, and we want to wait what? We have just what? They say we have just 3 minutes. The people that are timing us at the background, my lovely wife that is timing me, to make sure that we does not what? We don't go out of time. We want to say 8 to 9, our 8 to 9 should be 8 to 9. Because I know if our lovers, we have 1 or 2 things they want to do. So we want to do it, and anyone we cannot touch, please, and please don't be angry with us. Just what? Signal us with those questions and we'll solve it for you. So that is to say that the relative density or relative density times 1000 with kilogram per meter cube is equal to what? Density. How to convert density. And don't forget, volume in centimeter cube, 1 cm cube is equal to what? 10 raised by what? Minus 6 meter cube. Also, 1 liter is equal to 1000 what? Centimeter cube. Please don't forget. Very important, you know conversion. Also, relative density of what? Can also be in gram per meter cube. That means you can convert to gram per meter cube by what? Gram per centimeter cube. By the multiplying by what? 1 gram per centimeter cube. So you convert to density, have been converted to density. Relative density have been converted to density by multiplying by 1 gram per centimeter cube. Then you get your answer. Most of the time, relative density does not have a unit. Don't forget that the instrument used to measure relative density is called hydrometer, using the principle of what? Of flotation. And when a body is placed in water, there are these things that what? That act on 2 forces, which is weight and upthrust, that act on it. And when a body is what? In a granular form, to measure the what? The density or the relative density of the granular form or powder form of a substance, we use what? Density bottle to measure it. So that is just that. I believe you enjoyed the class, and we pray that God will help us to what? To continue, the grace to continue more, to be able to reach our people and make them learn better. God will give to us. And also the work we have learned so far, I just pray that God will give you a better understanding to comprehend everything we have done today. In Jesus' name, amen. Thank you very much. God bless you. Bye.